Hi, my name's Doug Ridge and I'm with Allegro DVT. In today's demonstration, what we're going to show you is a tool that we've developed to help our customers understand the impact of the constraints that they're putting on the video encoder and decoder IP in terms of the requirements to meet the demands of very high quality applications that are emerging. So if we look at those applications, first of all, we're now looking at things like automotive, AR and VR, and cloud gaming. And the applications have really been pushed from looking at 420 chroma sampling now to 444, from 8-bit samples to 12 bits, and from a varying degree of video encode quality to the highest possible, the best in class. We'll look today at H.264, HEVC, and AV1. So moving on to actually look at the tool itself now, it's a tool that we've developed for both the encoder and decoder and provides PPA information for the configuration. It's very easy to change, as you'll see, and it helps us and helps our customers understand what those changes will do in terms of the final silicon implementation. So let's take a look at it now. At the top level, this is what we see. This is the summary screen where we can provide the top level information, and what we see at the bottom is the information that comes out in terms of the frequency that the core needs to run at, the area in terms of both the logic and the internal memory, and even things like the power consumption. Now, I mentioned that this was the top level because you'll see the various tabs below that that cover things like frequency, area, power, the footprint, level 2 cache size, and bandwidth. So those are areas where we can get into much more detailed information, much more detailed discussion with customers to look at the requirements there in terms of where trade-offs can be made. So starting it off at this level, you'll see that we have the ALE100 selected. So this is one of Allegro's standard off-the-shelf encoder cores. And what I mean by that is that we have all of these, as you see listed on this drop-down menu. They're off the shelf, they're already there, and you can look at the configurations that they have. Now, they're not limited to a single encode format. So they do have two, maybe three different formats that they support in the one core. And they can be configured to support different formats or fewer formats, depending on the end application. And that's really what this tool is about, is there are the base implementations, but we can go a step beyond that to make sure that we have the optimal solution in the video encoder and decoder IP that we provide to our end customers, the optimal solution for their end application requirements. So what we'll do here is we'll select the E210, the E210E actually, which is the enhanced version. And the reason for selecting that is obviously you can go online and take a look at the performance of that one and the formats that it supports. But we're selecting it because we're looking at these very high-end requirements. We have a drop down here for the standard. I mentioned that these cores do support multiple standards, but what we're doing here with the tool right now is to look at one specific format and be able to understand the impact that decisions about that format and the way that it's implemented impact the overall silicon implementation. The level that we had for AVC was level 4, but in this case, we're going to select level 5.1. You'll see we cover all the different levels there. And the tier is set at main. It could be high as well. We only need it to be at main. Now, what you see in these two boxes is the fact that we don't have a drop-down menu for the picture width and picture height. And the reason for that is fairly obvious, that we can handle any width and any height of picture. So we're going to move from the HD that we're showing here to 4K. So let's just put in the numbers for 4K there. And so that's obviously already increased the amount of data that we have to process by 4. So we'll have an impact on the performance required from the core and the complexity of the implementation. The chroma format itself, 420, we mentioned, moving to 444. That has the impact, obviously, of, let's just look at it again to understand, moving from 420 to 444. We're seeing a doubling in the number of samples that need to be processed. So 100% increase there in the number of samples, added to the 4x increase in the number of pixels being processed. And we had selected 8-bit in the previous one. When we move to 10 and 12 bits, we're talking about the requirements for HDR, and we did mention the 12 bits, so we'll select that. So that's another 50% increase in data because we've increased the sample length by 50%. We'll keep the frame rate at 60 frames per second, but again, that can be changed. It's a free-form field again, as is the bitrate requirement. The number of cores is an interesting one because we can select the number of cores internally to allow us to target different silicon process geometries. So obviously, if we want the smallest implementation, we're going to have to run at a higher frequency. And if the process geometry doesn't allow that, then obviously we need to increase the number of cores or move to a different process technology. So all part of the discussion that we would have. And in this case, we've selected that we do have B frames and level 2 cache. The level 2 cache side of things, memory is a very complex thing within any of these implementations. And there's a great area for lots of discussion in terms of providing that optimal solution. The reduced memory bandwidth mode is also there. And all of these, as soon as we make any changes here, the impact on the implementation will be seen below. And of course, we can select the process geometry as well. And we've just set it as 16 for this case. So we would see all of these. Get in touch with us and let's get you more detailed information about your end application and be able to go through all of this with you at the top level and the finer granularity, as I mentioned as well. So now if we move back to the slide deck, the final slide then is just our conclusion that we have many considerations for a 444 12-bit with high VQ. There are the additional tools added for video quality. And understanding the project goals and trade-offs is key in terms of things like the memory constraints and architecture. And so now we're going to move into a Q&A session, and I hope to take your questions there. Thank you.